participants are not.
Good afternoon. Good afternoon, everyone. Good afternoon, everyone. Unacademy is congratulating ESC 2023 top rankers. Get an exam-like experience for GATE 2024. Exam is on 21st January. Appear All India mock test for GATE 2024 conducted by Unacademy. Unacademy is announcing Prarambh batch for GATE ESC PSS 2025. Batch commences from January 18th. Unacademy is announcing Vishwas batch for GATE ESC PSS 2026. Batch commences from January 18th. Welcome to the complete revision on engineering mathematics. Yeah, I am going to recall all problems related to matrix theory in this lecture. Vineet Shah, I am going to discuss all problems related to matrix theory in this lecture. Whenever concepts are required, I will discuss. Okay? Yeah. Now observe the problem. Let A be n cross n matrix. Let A be n cross n matrix with entries 0 and 1 and n greater than 1. If there is exactly 1 non-zero entry in each row and each column of A, then the determinant value of A must be. Yadav, not only matrix theory. Today I am going to cover entire matrix theory. Tomorrow calculus. Day after tomorrow vector calculus. Like that. Okay na? Let A be n cross n matrix such that let A be n cross n matrix with entries 0 and 1. If there is exactly one non-zero entry in each row and each column of A, then determinant value of A must be. Observe here. Let us take 2 cross 2 matrix. If your matrix is 2 cross 2, 1 0 0 1, determinant value is 1. 0 1 1 0, determinant value minus 1. So determinant value is either 1 or minus 1. Okay na? Determinant value is either 1 or minus 1. So according to the given conditions, if you take exactly one non-zero entry in each row and each column of A, remaining all entries are 0 in each row and each column of A, then determinant value must be either 1 or minus 1. Understood? Yeah, next problem. Let A be a 3 cross 3 matrix such that A into 2 minus 1 0 is 2 minus 1 0, A into minus 1 2 minus 1 is 2 minus 2 4 minus 2, A into 0 minus 1 2 is 0 minus 3 6. Suppose Q is 2 minus 1 0, minus 1 2 minus 1, 0 minus 1 2, then AQ is. Then what is AQ? Then what is AQ? Understood? Now, See, the problem is designed based on matrix multiplication. The problem is designed based on matrix multiplication. Observe general matrix multiplication. Observe here. Generally, if you multiply matrix A with matrix Q, result is AQ. Matrix A, matrix Q, result is AQ. How you are going to multiply? First row of A with first column of Q, result is 1 element. Second row with first column, 2 element. Third row with first column, 3 element. First row with first column, 1 Second row with first column, 2 Third row with first column, 3 That means you are getting first column of AQ. So matrix A multiplied with first column of Q, result is first column of AQ. Okay na? Matrix A multiplied with first column of Q is first column of AQ. Catch my point? So same logic we are going to apply here. Here matrix A, this is matrix A. 2 minus 1 0 is 2 minus 1 0 is first column of AQ, first column of Q. This is first column of Q. What is result? First column of AQ. Matrix A multiplied with second column of Q. The result is second column of AQ. Matrix A multiplied with third column of Q. This is third column of Q. The result is third column of AQ. Understood? So what is first column of AQ? First column of AQ is 2 minus 1 0. So this is not the option. This is not the option. 2 minus, third option is correct. 2 minus 1 0, minus 2 4, minus 2 0, minus 3 6. Understood? Understood? Right. Third option is correct. Next problem. The number of different n cross n symmetric matrices with each element being 0 or 1. The number of different n cross n symmetric matrices with each element being 0 or 1. How many number of different n cross n symmetric matrices you can generate with the help of 0 and 1? That is your question. Do one thing. First I am framing 2 cross 2 matrices. A matrix is said to be symmetric if A transpose equal to A. A transpose equal to A means the element appeared in ith row and jth column and jth row ith column must be equal. Okay, here all the entries are either 0 or 1. So observe 0 0. First row second column, second row first column are same. First row second column, second row first column are same. First row second column, second row first column are same. Remaining entries are 0 0, 0 1, 1 0, 1 1, 0 0, 0 1, 1 0, 1 1. Understood? In this case, all the matrices are symmetric. All the matrices are different. every entry of the matrix is either 0 or 1. So there are 8 different n cross n, 8 different 2 cross 2 symmetric matrices we have. So now problem is designed for n cross n. That's why in the place of n you put 2. 2 square is 4. It is incorrect. 2 power 2 square, it is not 8. 2 power 2 square minus 2 by 2, 4 minus 2 by 2, that is 2. It is incorrect. 2 square, 4, 4 plus 2, 6, 6 by 2, 3, 2 cube, 8. Last option is correct. Because in the case of 2 cross 2, there are 8 different symmetric matrices. So in the case of 2 cross 2, we have 8 different symmetric matrices. Next problem. Aij equal to Aij m cross n, where Aij is defined as I plus j for all ij. Then the sum of all elements of the matrix. Yeah, every element of the matrix is satisfying the condition that Aij equal to I plus j for all ij. Understood? Observe here. Matrix A, 1th element is 1 plus 1. 1/2th element is 1 plus 2. 1nth element is 1 plus n. 2th element is 2 plus 1. 2/2th element is 2 plus 2. 2nth element is 2 plus n. m1th element is m plus 1. m2th element is m plus 2. mnth element is m plus n. Observe here. 1, 1, 1. How many times? How many columns you have? N columns. So n number of ones. N number of ones. Plus 1 plus 2 plus 3 plus and so on n. N into n plus 1 by 2. Observe next one. 2, 2, 2. How many times? N times. N number of 2's plus 1 plus 2 plus and so on n. N into n plus 1 by 2. M. How many times? N times. N number of m's plus 1 plus 2 plus and so on n is n into n plus 1 by 2. By adding all these sums, we get n of 1 plus 2 plus and so on m plus n into n plus 1 by 2, n into n plus 1 by 2. How many times? M times. M number of n into n plus 1 by 2. N number of m into m plus 1 by 2 plus m number of n into n plus 1 by 2. Finally, mn by 2 of m plus n plus 1 plus 1, 2. So finally, mn by 2 of m plus n plus 2. Very good, Pavitra. Observe next problem. The number of different matrices that can be formed with the elements 0, 1, 2, 3. Each matrix having 4 elements. Each matrix having 4 elements. How many number of different matrices can be formed where each matrix having 4 elements? See, there are 4 elements now. He has not mentioned the order of the matrix. That's why 4 elements can be arranged 4 cross 1 form, 1 cross 4 form, 2 cross 2 form. 3 different forms. In each form, yeah, either in 1 cross 4 form or 4 cross 1 form or 2 cross 2 form, there are 4 blank places. There are 4 blank places because 4 elements na. So every blank place you can fill with either 0, R1, R2, R3. So 4 elements na. So every blank place can be filled in 4 ways. 4 into 4 into 4 into 4. That's why the total number of possible ways are 3 into 4 power 4. Understood? Therefore, the correct answer is 3 multiplied with 4 power 4. Next problem. This is the number of singular matrices of order 2. The number of singular matrices of order 2 where each element is either 0 or 1. Each element is either 0 or 1. Each element is either 0 or 1. Understood? How many number of singular matrices of order 2 where each element having either 0 or 1? Now observe. Two cross 2 matrices means there are 4 blank places. Every blank place can be filled with either 0 or 1. Either 0 or 1. That's why 2 into 2 into 2 into 2. Total 16. Total 16. Okay na? Now we have to calculate how many are singular. Singular. Now observe. To calculate singular, first I am calculating non-singular. Non-singular matrices are. Sir, how to calculate non-singular matrices? Observe, determinant value non-zero na? Concentrate. 1, 0, 0, 1 non-singular. 0, 1, 1, 0 non-singular. Next. Okay, green is not visible. Okay. Now 1, 0, 1, 1, 1, 1, 0, 1, understood? Total how many? 6 non-singular. All these are all non-singular. Therefore 6 non-singular. Now singular matrices are 16 minus 6, 10. 16 minus 6, 10. Therefore total 10 singular matrices we have. Understood? Right. The expansion of determinant of a square matrix consisting 120 terms, then the order of the matrix is the expansion of determinant of a square matrix consisting 120 terms, then order of the matrix is. Please observe, if the matrix is 2 cross 2, ABCD, the expansion is AD minus BC. Two terms. Two factorial. Suppose, it is 2 factorial. 2 terms is nothing but 2 factorial. Suppose if the determinant is 3 cross 3, ABC, XYZ, PQR, then the expansion consisting of YR minus QZ, XR minus PZ, XQ minus PY. Total how many terms? 6 terms. That is nothing but 3 factorial. Yes. 120 terms is nothing but 5 factorial terms. 120 terms is nothing but 5 factorial terms. 5 factorial means order of the matrix is 5. Order 5. Correct answer is 5. Matrix is 5 cross 5. Order is 5. Next problem. A, B, C, D, E are non-singular matrices of order. Same order. A, B, C, D are non-singular matrices of same order such that DA, BEC equal to I. Then B inverse is. We have to follow one technique here. What is the technique? Whenever you would like to find out B inverse starting from B, you have to follow counterclockwise order, ECDA. That is the correct answer. Understood? ECDA. Just you have to move counterclockwise order. Next problem. Determinant value of A cube is 125. Therefore, det A equal to 5. If det A is 5, what is det A from the data? Alpha square minus 4 equal to 5. alpha square equal to 9. Therefore, alpha equal to plus or minus 3. So, the correct answer is plus or minus 3. The value of alpha is plus or minus 3. Understood? Next problem. Let A be a 3 cross 3 matrix whose elements are Aij equal to I square minus j square for all ij. Then A inverse. Observe the matrix. A is Aij 3 cross 3. So it is a 3 cross 3 matrix. A11, A12, A13, A21, A22, A23, A31, A32, A33. That is nothing but A11 means 1 square minus 1 square 0, 1 square minus 2 square minus 3, 1 square minus 3 square minus 8, 2 square minus 1 square plus 3, 2 square minus 2 square 0, 2 square minus 3 square minus 5, 3 square minus 1 square 8, 3 square minus 2 square plus 5, 3 square minus 3 square is 0. Yeah, good afternoon, Vivedi. How is your preparation? Observe. Yeah, all the leading diagonal elements are 0. Matrix is 3 cross 3. Okay, na? Whenever problem demands concept, I will discuss. Okay, na? Anyhow, in every problem, I am revising the concept, na? It is a problem designed on simple concept. What is the concept? All the leading diagonal elements are 0. In which case all the leading diagonal elements are 0? Matrix is skew symmetric. So, skew symmetric. A skew symmetric matrix of odd order. If your matrix is a skew symmetric matrix of odd order, then determinant value of A equal to 0. We have a property. The determinant value of skew symmetric matrix of odd order is always 0. Odd order is always 0. Okay, na? That's why determinant value 0. If determinant value 0 hai to A inverse does not exist. If determinant value is 0, then the matrix is singular. Then A is singular matrix. Generally, for a singular matrix, determinant value does not exist. Determinant value does not exist when a matrix is singular matrix. Understood? Raju Kumar, mod A cube, it is not mod, it is determinant. Okay, na? Determinant of A cube is nothing but determinant of A into A into A. That is nothing but det A into det A into det A. That is nothing but det A whole cube. Raju Kumar, got the concept? Next one. The adjoint of the matrix is. The adjoint of the matrix is. Sir, to calculate adjoint of a matrix in the case of 3 cross 3, I have explained you one technique. Now I am explaining the technique. Observe. If your matrix is 3 cross 3, write middle last first middle. From middle column middle element, write the elements clockwise. 1 minus 2 minus 2. Minus 2, 1 minus 2. Two minus 1. 2 minus 1. 1 minus 2 minus 2. Okay. Now repeat first column once again. One minus 2 to 1. Now adjoint of A is, apply AD minus BC technique. 1 into 1 minus 4 minus 3. Minus 2 into minus 2 plus 4. Plus 4 plus 2 plus 6. Plus 4 plus 2 plus 6. Minus 4 minus 2 minus 6. Minus 1 plus 4 plus 3. Minus 4 minus 2 minus 6. Minus 4 minus 2 minus 6. Minus 4 minus 2 minus 6. Minus 1 plus 4 plus 3. Take 3 common. Minus 1 minus 2 minus 2. 2 1 minus 2. 2 minus 2 1. That is 3 into A transpose. So correct answer is 3 into A transpose. The rank of. Yes, Krishna. Very good. 3 into A transpose. What is the rank of the given 4 cross 4 matrix? Do one thing. First, I am interchanging R1 and R2 just for convenience. Okay, na? 1 minus 1 minus 2 minus 4. Next 2 3 minus 1 minus 1. 3 1 3 minus 2. Minus 6 3 0 minus 7. Observe the operations. R2 minus 2 times of R1 R3 minus 3 times of R1, R4 minus of R1 plus R2 plus R3. Now 1 minus 1 minus 2 minus 4, 2 minus 2 0, 3 minus of minus 2 5, minus 1 plus 4, minus 1 plus 4 plus 3, minus 1 plus 8 plus 7, 3 minus 3 0, 1 plus 3 4, 1 plus 3 4, 3 plus 6 9, minus 2 plus 12 plus 10, minus 2 plus 12 plus 10, now minus 6 plus 6 0, 3 plus, yeah, we are subtracting now, 3 minus 3 0, here it is minus 6307 na? Minus 6 means we have to add, by adding this we will get minus 6 plus 6 become 0. Here minus 1 plus 1 plus 3 plus 3 plus 6 na? This is plus 6. By adding all we will get 0. By adding all minus 14, minus 14, understood? Now apply 5 times of R3 minus 4 times of R2. One minus 1 minus 2 minus 4. 0 5 3 7. Now 5 times of R3, 4 times of R2. Then what happened? 0 minus 0, 0. 20 minus 20, 0. 5 9 ja, 45 minus 12. 3, 3, 33. 50 minus 28, 22. Next. Next. Operation. Five times of R4 minus 6 times of R2. 5, 6. Then what happened? This element is 0. This element is also 0. Now 0 minus 18. You'll get minus 18. Minus 70. Minus 6 7 ja 42. So minus 112. It is not in echelon form. If you apply further one operation, observe, Krishna, it is not rank 3. If it is plus 6, then rank 3. You are getting minus 6 here. Here, the element plus 6 aito, you will get rank 3. Okay na? Because of minus 6, you are getting rank 4. Observe here. 3322. Here 18 and 112. They are not proportional na? They are not proportional. That's why you will get rank 4. (33) times of R4 plus 18 times of R3. You'll get not green. We have to use only yellow color. Okay. One minus 2 minus 4. 0537 003322. By applying this operation, you will get 000 and minus 112. Minus 112 into 33. Okay. Plus 22 into 18. Minus 112 into 33 plus 22 into 18. You'll get minus 3300. Anyhow, it is an echelon form. Number of non-zero rows is called rank. Therefore, rank is 4. You are getting rank 4. Next problem. Yeah, the rank of a 3 cross 3 matrix is 2. Then the value of x is. Please look at the matrix. Automatically you will get idea. See, 3 cross 3 matrix. 3 cross 3 minor is non-zero rank. Rank will be 3. But they have given that rank is 2. What does it mean? Determinant value equal to 0. Otherwise, do one thing. You apply this operation. R3 minus R1 plus R2. R3 minus R1 plus R2. 472. 3 minus 1, 5. R3 minus R1 plus R2. 7 minus 7, 0. 6 minus 6, 0. X minus 7 has rank 2. Therefore, one row is 0 row. Therefore, last row is 0 row. Therefore, x minus 7 equal to 0. The value of x is 7. The value of x is 7. So, correct answer is 7. Understood? Yeah, next one. A is Aij, M cross N. Aij equal to 5 for all ij. Then rank of A. Sir, Aij equal to 5 for all ij means what? Every element of the matrix is 5. Aij equal to 5 for all ij means every element of the matrix is 5. If every element of the matrix is 5, all rows are identical. All rows are identical. If all rows are identical, rank of A is 1. Its rank is 1. Next one. Aij n cross n such that Aij equal to 3 for all ij. Then nullity of A. Then what is nullity of A? Nullity is nothing but dimension of null space. To calculate dimension of null space, first you have to calculate rank. Nullity is equal to total number of variables or columns minus rank. See here, total number of columns are 3. Rank is unknown. We have to calculate. Sir, we have solved the previous problem. If every element of the matrix is 5, its rank is 1. Here every element of the matrix is 3. So its rank is also 1. That's why 3 minus 1 is 2. Finally nullity is 2. But matrix is n cross n. If matrix is n cross n, total number of variables are, total number of columns are n. It is not 3 cross 3 matrix. That's why n minus 1 is the answer. That's why n minus 1 is the answer. Very good, very good. Anil and Krishna, Pavitra, right. If M is 3 cross 5 matrix with rank 3, N is 5 cross 7 matrix with rank 5, then rank of Mn. Tell me. Sir, rank of AB is less than or equal to minimum of rank of A comma rank of B. Therefore, 3 cross 5 matrix with rank 3, 5 cross 7 matrix with rank 5, minimum of 3 comma 5 is 3. Therefore, correct answer is second option. Concept based question. I hope you understand. If X is n cross 1 matrix, then rank of X into X transpose. If X is n cross n matrix, then rank of X into X transpose. If X is n cross 1 matrix, then rank of X into X transpose. What is the answer? Tell me. Sir, we have a property, rank of X equal to rank of X transpose equal to rank of X into X transpose equal to rank of X transpose into X. Therefore, what is correct answer? 1. 1, not n. 1. Rank of X transpose, rank of X into X transpose, rank of X transpose into X, all are equal. Next problem. The system of equations x plus 2ay plus az equal to 0, x plus 3by plus bz equal to 0, x plus 4cy plus cz equal to 0 has non-zero solution, then ABC are. Observe here. Ax equal to 0 has non-zero solution. Therefore, determinant value of A equal to 0. 1, 2a, 1, 3b, 1 4c c, 1 of 3bc minus 4bc minus 2a of c minus b plus a of 4c minus 3b equal to 0. Minus bc minus 2ac plus 2ab plus 4ac minus 3ab equal to 0. Okay na? Now minus bc minus 2ac plus 4ac is plus 2ac. 2ab minus 3ab is minus ab equal to 0. 2ac equal to ab plus bc. 2ac equal to b of a plus c. 2 by b equal to a plus c by ac. 2 by b equal to 1 by c plus 1 by a. 2 by b equal to 1 by c plus 1 by a means a, b, c are in harmonic progression. A, B, C are in harmonic progression. Understood? Right. Next one. The system of equations has non-zero solution. If the system of equations has non-zero solution when lambda equal to, first I am writing the given equations in homogeneous form, because this side x, right side also lambda x, here y, here lambda y, here y, here lambda z, here z, lambda z. So variable terms are left side as well as right side. First I am writing in homogeneous form. 1 minus lambda into x plus 2y plus 3z equal to 0. 3x plus 1 minus lambda into y plus 2z equal to 0. 2x plus 3y one minus lambda z equal to 0. It is clearly in the form of ax equal to 0. Ax equal to 0 has non-zero solution. Therefore, determinant value of a equal to 0. From this, we can write 1 minus lambda 2 3, 3 1 minus lambda 2, 2 3 1 minus lambda equal to 0. Now apply the operation. C1 plus C2 plus C3. If you apply the operation C1 plus C2 plus C3, then you'll get 6 minus lambda, 6 minus lambda, 6 minus lambda, 2 1 minus lambda 3, 3 2 1 minus lambda equal to 0. Take 6 minus lambda common. If you take 6 minus lambda common, you will get 1, 1, 1, 2, 1 minus lambda 3, 3, 2, 1 minus lambda, equal to 0. It is a into b equal to 0 form. Either a is 0 or b is 0. 6 minus lambda equal to 0, lambda equal to 6. Suppose lambda equal to 6, then determinant value equal to 0. If determinant value is 0, then the system possesses non-zero solution. Therefore, lambda equal to 6 is the correct option in this problem. Observe this problem. The system of equations ax plus y plus z equal to 0, x plus ay plus z equal to 0, x plus y plus az equal to 0 has infinitely many solutions. Then the set of values of a for this to happen is observe here. See, it is also a homogeneous solution. It is also a homogeneous system. In the case of homogeneous system, the system possesses infinitely many solutions. Means compulsory determinant value equal to 0. Determinant value equal to 0. So equate determinant value to 0. A11 1A1 11A equal to 0. Apply the operation. C1 plus C2 plus C3 now take A plus 2 common. One A1 1A equal to 0. A plus 2 multiplied with 1 of A square minus 1 minus 1 of A minus 1 plus 1 of 1 minus A equal to 0. A plus 2 into, if you take A minus 1 common, here you will get A plus 1 minus 1, here minus 1. Finally, A plus 2 into A minus 1 into A minus 1 equal to 0. Therefore, the value of A is minus 2 comma 1 comma 1. The set of values of A means minus 2 comma 1. So correct answer is minus 2 comma 1. Last option is correct. One comma minus 2 or minus 2 comma 1. Anil Yadav and Vinay Kumar. Pavitra. Yes. All are correct. Next problem, try this one. The system of equations has infinitely many solutions for what value of k? For k is equal to, sir, it is a non-homogeneous system. Whenever a non-homogeneous system is given, we have one procedure. First we have to consider augmented matrix AB. Consider augmented matrix AB. One, 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 one. 2, 3 minus 1, 5. 1, 2 minus k, 4. Now, R2 minus 2 times of R1. R3 minus R1. 1, 1, 1, 1. 2 minus 2, 0. 3 minus 2, 1. Minus 1 minus 2 minus 3. 5 minus 2 plus 3. Next. 1 minus 1, 0. 2 minus 1 is 1. Minus k minus 1. 4 minus 1 is 3. Next one. R3 minus R2. R3 minus R2. By applying these two operations, this operation we get 1, 1, 1, 1. 0 minus 1, 0, 1 minus 3, 3. 0 minus 0. 1 minus 1, 0. Minus k minus 1 plus 3. So minus k plus 2. 3 minus 3, 0. In the problem it is given that it has infinitely many solutions. When a non-homogeneous system possesses infinitely many solutions, it possesses infinitely many solutions when rank of A equal to rank of AB less than number of variables. It is possible. It is possible only when minus k plus 2 equal to 0. That means k equal to 2. If k is 2, then rank of A equal to 2, rank of AB equal to 2, number of variables equal to 3, both are equal and less than number of variables is possible. Then system possesses infinitely many solutions. Understood? That's why correct answer is k equal to 2. Observe next column. The system of equations has no solution for. The system of equations has no solutions for. First you have to consider augmented matrix AB. One, 1, 1, 6. 1, 4, 6, 20. 1, 4 lambda mu. Now observe, you have to apply the operations R2 minus R1, R3 minus R2. 1, 1, 1, 6, 1 minus 1, 0, 4 minus 1, 3, 6 minus 1, 5, 20 minus 6, 14, 1 minus 1, 0, 4 minus 4, 0, lambda minus 6, and mu minus 20. Please observe, you have two different values, lambda minus 6 and mu minus 20. Whenever you have two different values, there are four possible combinations. Sir, what are four possible combinations? First combination, lambda equal to 6, mu equal to 20. Second possible combination, lambda not equal to 6, mu equal to 20. Third possible combination, lambda not equal to 6, mu not equal to 20. Fourth possible combination, lambda equal to 6, mu not equal to 20. In all these four possible combinations, first I am talking about first combination, lambda equal to 6, mu equal to 20. When lambda equal to 6 and mu equal to 20, in this combination, what is rank of A and rank of AB and the number of variables? Please observe. When both are equal, this becomes 0, this becomes 0, last row becomes 0 row. Then rank of A equal to 2, rank of AB equal to 2, number of variables 3. In this case, the system possesses infinitely many solutions. Okay na? Suppose lambda not equal to 6, mu equal to 20. Lambda not equal to 6 matlab lambda minus 6 non-zero. Then rank of A equal to 3. In this case, rank of A 3, rank of AB 3, number of variables 3. All are equal. So, unique solution. Unique solution. Understood? Now, in the case of lambda not equal to 6, mu not equal to 20, both are non-zero. Both are non-zero. In that case, rank of A is 3, rank of AB is 3, number of variables 3. In this situation also, you will have unique solution. So, in these two cases, unique solution. In this case, infinitely many solution. Now last case. What is last case? Lambda equal to 6, mu not equal to 20. Lambda equal to 6, mu not equal to 20. In this case, rank of A is 2. Rank of AB is 3. Number of, you need not write number of variables because rank of A and rank of AB both are not equal. Na? When rank of A is 2, rank of AB is 3, both are not equal, then system possesses no solution. So the system possesses no solution when lambda equal to 6 and mu not equal to 20. Lambda equal to 6 and mu not equal to 20. Understood? Next problem. The system of equations. The system of equations consistent when k is equal to. The system of equations are consistent when k is equal to. Consider. When we will say system is consistent, there is a solution. There is a solution means there is a point of intersection. If there is a point of intersection, there is a solution. See, you have three equations with two unknowns. Generally, to get the values of two unknowns, we require only two equations. Now I am solving like this. I am going to solve for x and y by using these two equations. I will get a solution, x value and y value. If these three equations are consistent, compulsory the third equation is satisfied by x and y. I will substitute. I am going to get the value of k. That is my logic. Understood? Now 2x plus y equal to 5. Another one, x minus 3y equal to minus 1, multiply with 2. 2x minus 6y equal to minus 2. Now subtract. Plus 2x minus 2x cancel. 7y equal to 7. Y equal to 1. The value of y is 1. Now substituting the value of y equal to 1 here. 2x plus 1 equal to 5. 2x equal to 4. X is equal to 2. The value of x is 2. So x value 2, y value 1. Clearly 2, 1 lies on the third straight line. 3x plus 4y equal to k. Therefore, compulsory 2, 1 lies on 3x plus 4y equal to k, since system is consistent. That's why 3 2 6 plus 4 into 1 4 equal to k. Therefore, the value of k equal to 10. Finally, the value of k is 10. Finally, the value of k is 10. Next, A is n cross n matrix such that A square equal to I. A is n cross n matrix such that A square equal to I. B is n cross 1 real vector. Then Ax equal to B has. Observe, A square equal to I. That is the given condition. Please observe. If A square is I, determinant value of A square is determinant value of I. Determinant value of A square equal to determinant value of I can be written as det A into det A is 1. Det A whole square is 1. Det A is plus or minus 1. If determinant is plus or minus 1, determinant is non-zero. If determinant is non-zero, the system possesses unique solution. The system possesses unique solution. Understood? Sir, A is 3 cross 4 matrix and Ax equal to B is inconsistent. A is 3 cross 4 matrix, Ax equal to B is inconsistent. Then highest possible rank of A. See, very simple. You have to apply simple logic to solve this problem. Sir, A is 3 cross 4 matrix. What about augmented matrix AB? Augmented matrix AB is of order compulsory 3 cross 5. Why 3 cross 5? One column extra. The difference between coefficient matrix and augmented matrix is you are going to write column B along with A. That's why one column extra. So augmented matrix AB is of order 3 cross 5. Therefore, maximum possible minor of augmented matrix AB is 3 cross 3. So you can conclude like this. Therefore, maximum possible rank of AB equal to 3. Called it equation 1. Maximum possible rank of augmented matrix is 3. But your question is maximum possible rank of coefficient matrix A. Now observe another hint. Ax equal to B is inconsistent. Ax equal to B is inconsistent. Ax equal to B is inconsistent. Therefore, rank of A not equal to rank of AB. Called it equation 2. From 1 and 2, rank of A is not equal to rank of AB. Maximum possible rank of AB is 3. Therefore, maximum possible rank of A not 3. Not at all 3. If it is not 3, what is the next possibility? Either 0 or 1 or 2. Therefore, since maximum possible, that's why therefore maximum possible rank of A equal to 2. Maximum possible rank of A equal to 2. Now, I hope you understand how to solve homogeneous system as well as non-homogeneous system. Now, problems on eigenvalues. Sir, what are the eigenvalues of matrix A? Eigenvalues of matrix A. Please observe, we have properties. Sum of eigenvalues equal to trace of the matrix, product of eigenvalues equal to determinant value of the matrix, like that. I am going to use that property. Determinant value of A is A times of A square minus 1 minus 1 of A minus 0. Now A cube minus A cube minus 2A. So what is conclusion? The product of eigenvalues must be A cube minus 2A. Here product A cube, here product 0, here product minus 4A cube, here product A cube minus 2A. That's why last option is correct. That's why last option is correct. Next problem. The eigenvalues of matrix A are, observe here, sir, 1 1 1 1 1 1 1 1 1. 3 rows are identical, even 2 rows are identical, determinant value 0. So product of eigenvalues must be 0. Here product non-zero, that's why it is wrong option. Next, sum of eigenvalues must be 3 because trace is 3. So here trace 0, here trace 1, here trace 3, product 0. 0 0 3 is correct, 100%. Next problem. The eigenvalues of matrix A 2 3 x y are 4 and 8. Then x and y values. Observe trace. trace of A equal to sum of eigenvalues. Here trace is 2 plus y. Sum of eigenvalues is 4 plus 8. Therefore, y equal to 12 minus 2, 10. Y is 10. Now, determinant value of A is product of eigenvalues. Det A 2y minus 3x. Two y minus 3x equal to 4 8 jar 32. Y value 10. Equal to 32. Minus 3x equal to 32 minus 20. Minus 3x equal to 12. X equal to minus 4. X equal to minus 4. Y equal to 10. X equal to minus 4. Y equal to 10. Next problem. The sum of eigenvalues of the matrix. Actually it is n cross n matrix. Here dots are not printed. Sum of eigenvalues equal to trace na. Sum of eigenvalues equal to trace of the matrix. The trace is given by 1 1th element, 2 2th element, 3 3th element, n nth element. Sum of 1 1th element, 2 2th element, 3 3th element, n nth element. Sir, 1 by 1 into 2 can be written as 1 minus 1 by 2. 1 by 2 into 3 can be written as 1 by 2 minus 1 by 3. 1 by 3 into 4 can be written as 1 by 3 minus 1 by 4. 1 by n into n plus 1 can be written as 1 by n minus 1 by n plus 1. Except first and last. Remaining all under cancellation. That's why correct answer is 1 minus 1 by n plus 1. That's why the correct answer is 1 minus 1 by n plus 1. Next problem. The product of eigenvalues of the matrix. Sir, generally product of eigenvalues equal to determinant value of the matrix. It is also n cross n matrix. Product of eigenvalues equal to determinant. One into 1 by 2 into 1 by 3 into and so on 1 by n. That is 1 by n factorial. So correct answer is 1 by n factorial. One by n factorial. Next. Suppose the matrix has a certain complex number, lambda not equal to 0 is an eigenvalue. Which of the following must be an eigenvalue of A? We have properties. Sum of eigenvalues equal to trace. Product of eigenvalues equal to determinant. It is a 3 cross 3 matrix. Therefore, lambda 1 plus lambda 2 plus lambda 3 equal to trace. 40 plus 30 minus 50. Lambda 1 plus lambda 2 plus lambda 3 equal to 20. Sir, one of the eigenvalue is lambda. One eigenvalue lambda. Other two eigenvalues are unknown. Okay na? Plus you have one property you observe. Sum of all elements of first row. 40 plus minus 29 minus 1, 0. Sum of all elements of second row, minus 18 minus 12 minus 30 plus 30, 0. Sum of all elements of third row, 26 plus 24, 50 minus 50, 0. Sum of all elements of each row is 0. Therefore, 0 is one of the eigenvalue. That's why one eigenvalue 0. So the second eigenvalue 0. Sir, what about third eigenvalue? 20 minus lambda. Third eigenvalue is 20 minus lambda. Understood? Right. Next column. Matrix A 0 1 2 0 0 0 1 0 2 1 0 2 0 0 2 0. Please look at the matrix. The matrix is a symmetric matrix. Matrix is symmetric. If the matrix is symmetric, the eigenvalues are real. That is one property. So here eigenvalues are real, but A has no real eigenvalue is wrong. See, if eigenvalues of A are real, whether they are positive real or negative real or some positive, some negative. Another point we have, in the matrix, trace is 0. Trace of A is 0. Trace of A 0 means sum of eigenvalues equal to 0. Sir, sum of eigenvalues 0 means, suppose if all eigenvalues are real, okay. Suppose all eigenvalues are positive real, sum of positive real cannot be 0. Sum of negative real cannot be 0. That's why some positive, some negative is the correct answer. Both positive and negative real is correct option. That's why last option is correct in this problem. That's why A has both positive and negative real. A has both positive and negative real. Next problem. The number of linearly independent eigenvectors of the matrix. How many number of linearly independent eigenvectors of the given matrix? How many number of linearly independent eigenvectors for the given matrix? Observe. To know how many number of independent eigenvectors, first we have to calculate eigenvalues. To calculate eigenvalues, we have one technique, partition technique. Divide the matrix into 4 equal parts. It is clearly in the form of B00C. If you calculate eigenvalues of B and eigenvalues of C, automatically you will get eigenvalues of original matrix A. Now, two minus lambda 2, 1 minus lambda equal to 0. That is 2 minus 2 lambda minus lambda plus lambda square minus 4 equal to 0. Lambda square minus 3 lambda minus 2 equal to 0. From this, lambda equal to 3 plus or minus square root of 9 plus 8 by 2. 3 plus or minus root 17 by 2. That is 3 plus root 17 by 2. 3 minus root 17 by 2. Next one. Determinant of 3 minus lambda 0. 1. 4 minus lambda equal to 0. 3 minus lambda into 4 minus lambda equal to 0. Therefore, lambda equal to 3 comma 4. See here, you have 4 eigenvalues, but all 4 eigenvalues are different. 3 plus root 17 by 2. 3 minus root 17 by 2. 3, 4. Since all 4 eigenvalues are different, for every different eigenvalue, there exists one independent eigenvector. Corresponding to lambda 1, there is x1. Corresponding to lambda 2, there is x2. Corresponding to lambda 3, there is x3. Corresponding to lambda 4, there is x4. All 4 eigenvalues are different. Therefore, all 4 eigenvectors are different. All 4 eigenvectors are different. Understood? Next problem. If the characteristic roots of 3, 7, 2, 5 are lambda 1, lambda 2, then the characteristic roots of 5 minus 7 minus 2, 3 are, observe here, this is A. This is nothing but adjoint of A. Okay, na? If we have property, if lambda 1, lambda 2 are eigenvalues of A, then det A by lambda 1, det A by lambda 2 are eigenvalues of adjoint A. In our problem, lambda 1, lambda 2 are eigenvalues of given matrix. Now we have to calculate eigenvalues of adjoint A. So first I have to calculate det A. What is det A? 15. What is det A? AD minus BC. 15 minus 14. Det A is 1. In this problem, det A equal to 1. Therefore, 1 by lambda 1, 1 by lambda 2 are eigenvalues of adjoint A. So correct answer is 1 by lambda 1, 1 by lambda 2. Understood? Next problem. Let A be a 3 cross 3 matrix whose characteristic roots are 3 comma 2 comma minus 1. If B is A square minus A, then determinant value of B is. See, eigenvalues of A are provided. Eigenvalues of A are 3, 2, minus 1. Therefore, eigenvalues of A square are 3 square, 2 square, minus 1 whole square. Eigenvalues of A are 3, 2, minus 1. Therefore, eigenvalues of A square minus A are, you have to calculate eigenvalues of A square minus A only. 9 minus 3, 6. 4 minus 2, 2. 1 minus of minus 1, 2. Since A square minus A is B, this is B. Therefore, determinant value of B is 6 into 2 into 2. 6 4 ja 24. Therefore, det B is 24. Therefore, det B is 24. Next problem. If A is a 3 cross 3 matrix, it is a triangular matrix, then trace of A power 1 or 2. Please concentrate. Excellent problem. It is a triangular matrix. Eigenvalues of triangular matrix are its leading diagonal elements. Therefore, eigenvalues of A are 1, minus 1 by 2 plus I root 3 by 2. Minus 1 by 2 minus I root 3 by 2. 1 is 1. Minus 1 by 2 plus I root 3 by 2 is omega. Minus 1 by 2 minus I root 3 by 2 is omega square. Sir, what is omega? Observe. Omega means e power I 2 pi by 3 cos 2 pi by 3 plus I sin 2 pi by 3. Cos 2 pi by 3 is minus 1 by 2. Sin 2 pi by 3 is root 3 by 2. That's why I have written minus 1 by 2 plus I root 3 by 2 as omega. Understood? Now, omega square means e power I 4 pi by 3. E power I 2 pi by 3 whole square. That is nothing but e power I 4 pi by 3. That is nothing but cos 4 pi by 3 plus I sin 4 pi by 3. 4 pi by 3 means 240 degrees. Third quadrant, cos theta negative, sin theta negative. Minus 1 by 2 minus I root 3 by 2. That's why minus 1 by 2 minus I root 3 by 2 I have written omega square. I hope you understand why it is 1 omega square. Now, eigenvalues of A power 1 or 2 are 1 power 1 or 2, omega power 1 or 2, omega square whole power 1 or 2. 1 power 1 or 2 is nothing but 1. Omega power 1 or 2 is nothing but omega cube whole power 34. Omega square whole power 1 or 2 is omega square whole cube whole power 34. This is 1. Omega cube is 1. Omega square whole cube is also 1. So 1, 1, 1 are eigenvalues of A power 1 or 2. Therefore, Trace of a power 1 or 2 is 1 plus 1 plus 1, that is 3. Trace of a power 1 or 2 is 3. Next, if a 3 cross 3 real skew symmetric matrix has eigenvalue 2i, then one of the remaining eigenvalue of A is, see, A is a 3 cross 3 skew symmetric na. If A is a 3 cross 3 skew symmetric, we have one property. Sir, determinant value of skew symmetric matrix of odd order is 0. If that A is 0, product of eigenvalue is 0. If product of eigenvalue is 0, at least one of the eigenvalue 0. Since product is 0 means compulsory at least one of the eigenvalue 0. That's why correct answer is third option. Next problem. Let A be a 3 cross 3 matrix with eigenvalues -1, 1, 10, -1, 1, 10, -1, 1, 0. Then determinant value of a power 100 plus I is, eigenvalues of A are -1, 1, 0. Sir, what about eigenvalues of a power 100? -1 power 100, 1 power 100, 0 power 100. Eigenvalues of I are 1, 1, 1. Eigenvalues of I are 1, 1, 1. Therefore, eigenvalues of a power 100 plus I are, observe, 1 plus 1, 2, 1 plus 1, 2, 0 plus 1, 1. Now, determinant value of a power 100 plus I, 2 into 2 into 1, 4. Answer is 4. Answer is 4. Understood? A matrix M has eigenvalues 1 and 4 with eigenvectors 1 minus 1, 2, 1 respectively. Then the matrix M is. So matrix is unknown. Use the necessary and sufficient conditions for the existence of eigenvalues. Let us assume matrix is ABCD. One minus 1 equal to 1 into 1 minus 1. ABCD multiplied with 2, 1 equal to 4 into 2, 1. Now observe. A minus B, C minus D equal to 1 minus 1. 2A plus B, 2C plus D. 2a plus b equal to 8, 2c plus d equal to 4. Now 3a equal to 9, 3c equal to 3, a equal to 3, b equal to 2, c equal to 1, d equal to 2. Therefore, the matrix is 3, 2, 1, 2. So correct answer is third option. Got it? Next problem. Let A be a 2 cross 2 matrix. Suppose 2 minus 1 and 1 0 are eigenvectors corresponding to eigenvalues 1 and 2 respectively. Then the matrix A is. Similar problem. How we have solved previous problem? Similar model. Let us assume matrix is ABCD. Multiplied with 2 minus 1 equal to 1 into 2 minus 1 1 0 equal to 2 into 1 0 now 2a minus b 2c minus d equal to 2 minus 1 a plus 0 c plus 0 equal to 2 0 a equal to 2 c equal to 0 a equal to 2 c equal to 0 in which option? Third option. Clear na? Otherwise substitute here. 2a means 4 minus b equal to 2, therefore b equal to 2. 2c means 0, d equal to 1. So the matrix is 2 2 0 1. 2 2 0 1, third option. Understood? Right. Next column. A is a 3 cross 3 real matrix. Suppose 1 and minus 1 are two of the three eigenvalues of A. Actually, A is 3 cross 3 matrix, na? So it has 3 eigenvalues. They have provided 1 and minus 1. Third eigenvalue they have not provided. 18 is one of the eigenvalue of A square plus 3A. Then, now observe. Lambda 1 minus 1 are eigenvalues of matrix A. Lambda square 1 square minus 1 whole square are eigenvalues of matrix A square. Three lambda 3 minus 3 are eigenvalues of matrix 3A. Now lambda square plus 3 lambda, 1 plus 3 4, 1 minus 3 minus 2 are eigenvalues of A square plus 3A. So the eigenvalues of A square plus 3A are lambda square plus 3 lambda 4 minus 2, because it is a 3 cross 3 matrix. In the problem it is given that one of the eigenvalue of A square plus 3A is 18. So this is 18. Therefore determinant value of A square plus 3A is 18 into 4 into minus 2, that is minus 144. That is non-zero. That is non-zero. Therefore A square plus 3A is inversible. A square plus 3A is inversible. Next, come to the point. Sir, lambda square plus 3 lambda equal to 18. Suppose lambda is 0, then 0 equal to 18. Mathematically wrong. Therefore, clearly we can understand that lambda value is 100% non-zero. If lambda is non-zero, if this is non-zero, non-zero value into 1 into minus 1 non-zero. That's why det A non-zero. Therefore det A non-zero. If det A is non-zero, A is non-singular. If A is non-singular, matrix A is inversible. Matrix A is inversible. So finally the conclusion is A is inversible and A square plus 3A are also inversible. So both are inversible is the correct option. Both A and A square plus 3A are inversible. Understood? Next problem. Matrix M is a complex matrix. It is a complex matrix. Look at the matrix. Principal diagonal elements are real. That is first hint. Leading diagonal elements are real. And A12 and A21 are, A12 is 1 plus I, A21 is 1 minus I, complex conjugates. A13 is 2I, A31 is minus 2I, complex conjugates. Second row, fourth column, 7 minus I. Fourth row, second column, 7 plus I, complex conjugates. Third row, fourth column, I. Fourth row, third column, minus I, complex conjugates. That means we can understand that Aij equal to Aj bar for all Ij. That means A power theta equal to A. Therefore, A is Hermitian matrix. Okay, na? A is a Hermitian matrix. If the matrix is Hermitian, whose eigenvalues are real. Now, we can understand that M has real eigenvalues is the correct option. It is not A, it is M. M has real eigenvalues. The matrix has real eigenvalues is the correct option. Let A is m cross n, B is n cross m. Determinant value of I plus AB equal to determinant value of I plus BA. Then determinant value of a 4 cross 4 matrix is. Observe, I am going to use operation technique to solve this problem. Please observe. I am going to write the matrix 2 triple 1. 1 2 double 1, 1 1 2 1, 1 1 1 2 equal to observe here. If all 4 rows are identical, compulsory 3 of the eigenvalues are 0. Fourth eigenvalue is nothing but 4. Okay, now these are eigenvalues of this matrix. What about eigenvalues of identity matrix? 1 1 1 1. Eigenvalues of identity matrix are 1 1 1 1. Now eigenvalues of original matrix are 0 plus 1, 0 plus 1, 0 plus 1, 4 plus 1, 5. Therefore, determinant value is product of eigenvalues 5. Determinant value is 5. I have written given matrix in the form of sum of one identity matrix and other matrix. If you know eigenvalues of A and eigenvalues of I, you can easily calculate eigenvalues of A plus I. That's why I have applied that property. Concentrate here. The eigenvector corresponding to the largest eigenvalue of the matrix is largest eigenvalue of the matrix. So first you have to calculate eigenvalue. Then only you can identify that which one is largest. First I am going to calculate eigenvalues of matrix A by writing determinant of A minus lambda equal to 0, 2 minus lambda 1 1, 1 2 minus lambda 1, 0 0 1 minus lambda, equal to 0. Now 1 minus lambda of 2 minus lambda whole square minus 1 equal to 0. Lambda square minus 4 lambda plus 4 minus 1. Lambda square minus 4 lambda plus 3 is lambda minus 1 into lambda minus 3 equal to 0. From this you can write lambda equal to 1 comma 1 comma 3. Lambda equal to 1 comma 1 comma 3. So what is the largest eigenvalue? 3 is the largest eigenvalue. So corresponding to lambda equal to 3, we have to consider eigenvector. Corresponding to lambda equal to 3, we have to find eigenvector. Two minus 3 minus 1, 1 1. 1 2 minus 3 is minus 1. 1 minus 1 1. 0, 0, 1 minus 3. Select any two non-zero rows. Right, middle, last, first, middle. Middle 1, 1 minus 1, last 1, 1, first minus 1, 1, middle 1 minus 1. X1 by 1 plus 1, X2 by 1 plus 1, X3 by 1 minus 1. After cancellation, you'll get X1 by 1, X2 by 1, X3 by 0. Therefore, the eigenvector is 1, 1, 0. 1, 1, 0 is the corresponding eigenvector. One, 1, 0 is corresponding eigenvector of A. The 1, 1, 0 is eigenvector corresponding to lambda equal to 3. So correct answer is 1, 1, 0. Understood? Next problem. Matrix is provided. Our job is to calculate eigenvector. Simply you can understand that from the partition technique. One of the eigenvalue 5. You verify Ax equal to 5x. Which equation, which matrix is, which eigenvector is satisfying Ax equal to 5x. Okay, na? So select from the options. First, Ax. Ax must be equal to 5x. Matrix A is 5, 0, 0, 0, 0, 5, 5, 0, 0, 0, 2, 1, 0, 0, 3, 1, 1 minus 2, 0, 0, LHS 5 plus 0 plus 0 plus 0, 0 minus 10 plus 0 plus 0, 0 plus 0 plus 0 plus 0, 0 plus 0 plus 0 plus 0 is equal to 5 minus 10, 0, 0. LHS equal to RHS. Therefore, we can conclude that first option satisfies Ax equal to 5x. First option satisfies Ax equal to 5x. Therefore, first option is correct. Observe next column. Let P and Q be square matrices such that PQ equal to I. Then 0 is eigenvalue of. If PQ equal to I, then 0 is eigenvalue of. If PQ equal to I, determinant value of P equal to determinant value of I. Det P into det Q equal to 1. Therefore, det P non-zero, det Q non-zero. If det P is non-zero, product of eigenvalues non-zero. Det Q non-zero, product of eigenvalues non-zero. Therefore, each eigenvalue non-zero. Each eigenvalue non-zero. Therefore, 0 is eigenvalue of neither P nor Q. 0 is eigenvalue of neither P nor Q. Next problem. Let A is n cross n matrix is defined as Aij equal to I for all I equal to j, which is 0 otherwise. The sum of all eigenvalues of matrix A. Aij equal to I. Aij equal to I means matrix is n cross n. A11 is 1. A22 is 2. A33 is 3. Ann is n. Remaining all entries are 0. Remaining all entries are 0. If remaining all entries are 0, now observe. Sum of eigenvalues equal to trace. Sum of eigenvalues equal to trace. That is 1 plus 2 plus and so on n. N into n plus 1 by 2. N into n plus 1 by 2. Next problem. Sir, matrix is 3 cross 3 has eigenvalues 5 minus 3, 3. The eigenvector corresponding to 5 is 1, 2, minus 1. Then eigenvector of AQ. Please observe. Eigenvectors of A. A square, A cube, A power 4 and so on A power n are always same. Always same. That's why eigenvector is 1, 2, minus 1. One, 2, minus 1. Same eigenvector will come. Next problem. Consider the matrix A square AB AC, AB B square BC, AB B square BC, and AC BC C square, AC BC C square. ABC are non-zero real numbers. Then the matrix has 3 non-zero real eigenvalues or complex eigenvalues or 2 non-zero eigenvalues or only 1 non-zero eigenvalue. Please observe the matrix. Our matrix is in the form of A into ABC. Second row is nothing but B into ABC. Third row is nothing but C times of ABC. So what is conclusion? All the rows are proportional. All rows are proportional. 3 rows are proportional. You can say like this. 3 rows are proportional. If 3 rows are proportional, compulsory 2 of the eigenvalues are 0. Two eigenvalues are 0. Compulsory 2 of the eigenvalues are 0. 2 eigenvalues are 0. Sir, what about third eigenvalue? A square plus B square plus C square. Trace. Sum of eigenvalues must be equal to trace of the matrix, na? That's why, since A, B, C are non-zero real, therefore this is also non-zero. So how many non-zero eigenvalues? One and only one non-zero eigenvalue is the correct option. One and only one non-zero eigenvalue is the correct option. Understood? One and only one non-zero eigenvalue is the correct option. Next. Observe the problem. Here, leading diagonal elements are real. 3 plus 2i, 3 minus 2i, 6i minus 6i. Okay, na? Therefore, m power theta equal to m. M is Hermitian. Eigenvalues of m are real. M is Hermitian, eigenvalues of m are real. If m is Hermitian, Im is Q-Hermitian. That's why this is true. This is also true. Q and R only is the correct option. Understood? If A is equal to ABCD, A plus D equal to AD minus BC equal to 1, then A cube equal to. It is a problem designed on Cayley-Hamilton theorem. First, we have to calculate characteristic equation. Now, AD minus A lambda minus D lambda plus lambda square minus BC equal to 0. Lambda square minus A plus D into lambda plus AD minus BC equal to 0. Since A plus D equal to 1, AD minus BC equal to 1. Lambda square, A plus D is 1, now 1 into lambda is lambda, plus AD minus BC is 1, equal to 0. That is called equation 1 by Cayley-Hamilton theorem. A square minus A plus I equal to 0. a square equal to a minus I. Multiply this equation on both sides with a. A cube equal to a square minus a. Since a square is a minus I minus a cancel, that is minus I. Finally, a cube is minus I. Finally, a cube is minus I. Understood? Next problem. Let A be n cross n complex matrix whose characteristic polynomial is t power n plus cn minus 1 into t power n minus 1 plus c1t plus c0. Then determinant value of A is. See here, if the matrix is 2 cross 2, characteristic equation is a lambda square plus b lambda plus c equal to 0. Then product of roots equal to c by a. Suppose if your matrix is 3 cross 3, characteristic polynomial is a lambda cube plus b lambda square plus c lambda plus d. Then product of roots is minus d by a minus d by a, because odd order, degree is odd. Next, in the case of n cross n, product of roots is minus 1 whole power n into constant term by coefficient of lambda power n. Because if n is even, you will get plus 1. If n is odd, you will get minus 1. That's why. In our problem, n is unknown. So it can be even or it can be odd. That's why you have to write minus 1 whole power n. Constant term. What is constant term here? C0. C0. That's why C0 by coefficient of t power n 1. See, product of eigenvalues is always equal to determinant value of the matrix. Therefore, det A equal to minus 1 whole power n into C0. Minus 1 whole power n into C0 is the correct answer. Understood? Now, next problem. Let A be a 4 cross 4 matrix with the real entries such that minus 1, 1, 2 minus 2 are its eigenvalues. If B is a power 4 minus 5a square plus 5i, then which of the following is incorrect? Observe here, eigenvalues of A are minus 1, 1, minus 2, 2. Eigenvalues of A square are 1 square, minus 1 whole square, 1 square, minus 2 whole square, 2 square. Eigenvalues of A power 4 are 1, 1, 16, 16. Now our job is to calculate A power 4 minus 5a square plus 5i. Now, eigenvalues of A power 4 minus 5a square plus 5i 1, 1, 1, 1. This is nothing but matrix B na. Therefore, eigenvalues of A are minus 1, 1, minus 2, 2. Eigenvalues of B are 1, 1, 1, 1. Minus 1 plus 1, 0. 1 plus 1, 2. Minus 2 plus 1, minus 1. 2 plus 1, 3. Minus 1, minus 1, minus 2. 1 minus 1, 0. Minus 2 minus 1, minus 3. 2 minus 1, 1. Now, determinant value of B is 1. Therefore, this statement is true. Determinant value of A plus B 0. Because one of the eigenvalue 0 na. That's why a determinant value of A plus B 0. So that statement is also true. Trace of A plus B 4. Here I am calculating trace of A plus B. 0 plus 2, 2, 2 minus 1, 1, 1 plus 3, 4. That statement is also true. Which one is false? Trace of A minus B 0. That is false. Because trace of A minus B is minus 4. But they have given 0. That's why it is false. So our job is to calculate incorrect statement. Incorrect statement is last option. Understood? Incorrect statement is last option. Not visible. Anil? Atul Yadav? Not visible. Okay. Eigenvalues of A are given that minus 1, 1, minus 2, 2. Eigenvalues of A square are 1, 1, 4, 4. Eigenvalues of A power 4 are 1, 1, 16, 16. Based on that, I have calculated eigenvalues of A power 4, minus 5A square and 5i. That is nothing but matrix B. Understood? The constant term in the characteristic polynomial of the matrix is, see, we have one property. Sir, det A equal to minus 1 whole power n into constant term by coefficient of lambda power n. Det A equal to, our problem is 4 cross 4, minus 1 whole power 4, constant term by coefficient of lambda power 4. Det A equal to minus 1 whole power 4 is 1. Constant term by coefficient of lambda power 4 constant term by coefficient of lambda power 4 equal to det A. Now det A, observe here, third row equal to 2 times of R1. Therefore det A value 0. Det A is 0. Constant term is 0. Finally, constant term is 0. Understood? Next. Aij equal to 1 for all ij. Then the number of different independent eigenvalues of A are. How many different eigenvalues of A we have? Observe. If every element of the matrix is 1, matrix is n cross n. See, n rows are identical. If n rows are identical, how many eigenvalues are 0? n minus 1 times eigenvalues are 0. One eigenvalue n. That is trace. So now, number of different eigenvalues equal to one eigenvalue 0, another eigenvalue n. How many distinct eigenvalues you have? Two distinct eigenvalues. Next problem. Yeah, this is the last problem. Observe. Which is a problem designed on Cayley-Hamilton theorem. Matrix A is 1 0 0 0 1 1 0 minus 2 4. First we have to write characteristic equation of A. One minus lambda 0 0. 0 1 minus lambda 1. 0 minus 2 4 minus lambda. One minus lambda into 4 minus lambda plus 2 equal to 0. 1 minus lambda into lambda square minus 5 lambda plus 4 plus 2 equal to 0. Lambda square minus 5 lambda plus 6 minus lambda cube plus 5 lambda square minus 6 lambda equal to 0. That implies minus lambda cube plus 6 lambda square minus lambda cube plus 6 lambda square minus 11 lambda plus 6 equal to 0. Lambda cube minus 6 lambda square plus 11 lambda minus 6 equal to 0. Called it equation 1 by Cayley-Hamilton theorem. A cube minus 6a square plus 11a minus 6i equal to 0. 6i equal to a cube minus 6a square plus 11a. We have to calculate 6a inverse. Multiply this equation with a inverse. 6a inverse equal to a square minus 6a plus 11i. So the conclusion is 6a inverse equal to a square minus 6a plus 11i. Given that in the data it is given that 6a inverse equal to a square plus ca plus di. By comparing these two, we can conclude that the value of c is minus 6, the value of d is 11. Therefore, c comma d is minus 6 comma 11. C comma d is minus 6 comma 11. So correct answer is first option. Understood? Yeah, sure. Thank you. List of books home delivered within 15 days for iconic subscriptions. Unacademy is congratulating GATE 2023 top rankers. Unacademy is conducting daily scholarship test. Take a test for free and win up to 50% scholarship. Thank you.